Dr. Kim Doo-ha stared at her computer screen in the dim light of her office at the Busan Deep Sea Research Institute. The numbers didn't make sense. She checked them again, then a third time. The deep-sea coral samples were dying much faster than they should be. She rubbed her tired eyes and looked at the clock on the wall. It was already past midnight, but she couldn't leave yet. Not when she might be looking at something this important. The last 6 months of data from the deep-sea sensors showed coral death rates that were 5 times higher than any previous records. This can't be right, she said to herself, reaching for her 4th cup of coffee. The ceramic mug felt cold in her hands. She had been so focused on her work that she'd forgotten to drink it. A soft knock on her door made her look up. Lee Ji-won, her colleague who worked with the deep-sea vehicles, stood in the doorway. His usual neat appearance was wrinkled from a long day of work. "You're still here?" he asked, walking into her office. "I saw the light on when I was leaving." "Ji-won, look at this," Doo-ha said, waving him over to her computer. "These are the readings from the Mariana Trench sensors. Look at the pH levels." Ji-won leaned in, his eyes scanning the graphs on the screen. His tired expression changed to one of concern. "That's impossible. The acid levels shouldn't be changing this fast." "But they are," Doo-ha said, pulling up another screen. "And it's not just there. Look at the data from the Philippine Trench and the Japan Trench. The same pattern everywhere." She showed him a map covered in red dots. Each dot represented a sensor, and almost all of them were showing dangerous changes in the water's chemistry. "Something is speeding up the acidification process," she explained, using her finger to trace the pattern. "See how it spreads out from the thermal vents. It's like there's a chemical reaction we didn't know about before." Ji-won pulled up a chair and sat down beside her. "If this is real, it's not just about the corals. The whole deep-sea ecosystem could be in danger." Doo-ha nodded, opening a folder of pictures on her computer. The images showed before and after shots of deep-sea coral reefs. The after pictures were taken just a week ago. Where there had once been colorful coral gardens full of life, now there were only gray, lifeless structures. "We need more data," Ji-won said, but Doo-ha was already shaking her head. "We don't have time for more data collection. Look at this," she typed quickly, pulling up a chart that showed death rates of deep-sea creatures. "We're losing entire species before we even discover them. Whatever is happening down there, it's getting worse every day." Ji-won was quiet for a moment, thinking. "The research vessel is due for another deep-sea run next week. I can change the route, get closer to some of these hot spots." "Do it," Doo-ha said firmly. "And Ji-won, we need to tell the director about this first thing tomorrow. This isn't just a local problem anymore. If these readings are right, we're looking at a crisis that could affect every ocean on Earth." Ji-won stood up, his face serious. "I'll call an emergency meeting for tomorrow morning. Try to get some sleep, Doo-ha. Tomorrow is going to be a long day." After he left, Doo-ha turned back to her computer. Sleep wasn't an option, not when she had to prepare her findings for the meeting. As she worked through the night, organizing data and preparing her presentation, she couldn't shake the feeling that they had stumbled onto something much bigger and much more dangerous than anyone had expected. The oceans were changing, and they were changing fast. Unless they could figure out what was causing it and find a way to stop it, the consequences would be devastating. As she looked at the glowing red dots on her map one more time, Doo-ha knew that her discovery was just the beginning of what would become the biggest challenge of her career, and perhaps the biggest threat the world's oceans had ever faced. 1 week after Dr. Kim Doo-ha's discovery, Lee Ji-won sat in the control room of the deep-sea research vessel Ocean Explorer, watching the live feed from their underwater cameras. What he saw made his stomach turn. The seafloor looked like a graveyard, where their last expedition had recorded thriving communities of deep-sea creatures. Now there was only empty shell fragments and lifeless coral skeletons. The vehicle's lights swept across the dark water, revealing more and more signs of destruction. "Move closer to the thermal vent," Ji-won instructed the pilot. The large underwater vehicle slowly approached the hot water vent that usually supported rich, deep-sea life. The screen showed nothing but empty rock formations. His phone buzzed. It was a message from Dua. "How bad is it?" Jai-Won took a photo of the screen and sent it to her. Her response came quickly. "This matches what we're seeing everywhere. The international research stations just shared their data. It's happening in every ocean." The pilot's voice interrupted his thoughts. "Sir, we're picking up something strange on the sensors." Jai-Won looked at the readings. The water around the thermal vent was showing unusual chemical patterns. It was as if the hot water coming from the Earth's crust was triggering a new kind of chemical reaction, making the water more acidic than ever before. Back at the research institute, Duha was dealing with a crisis of her own. Scientists from around the world were calling emergency meetings. Reports were coming in from every major ocean research center. The Great Barrier Reef team reported massive die-offs. The Mediterranean research stations were recording the fastest peak changes in history. Even the Arctic researchers were seeing problems in waters that had been stable for centuries. She joined an emergency video conference with other leading scientists. On her screen, worried faces from different countries appeared one by one. "The Pacific deep sea stations are showing the worst damage," reported Dr. Chen from Taiwan. "The Atlantic isn't far behind," added Dr. Martinez from Brazil. "We've lost contact with 3 of our deep water sensor networks. The acid levels are literally eating through the protective casings." Duha shared her team's findings. "The reaction seems to be spreading from the thermal vents. Something in the Earth's crust is changing the ocean's chemistry. Traditional models can't explain how fast it's happening." The discussion was interrupted by an urgent message from Ju-Won. The ocean explorer had found something new. Duha opened the video feed on her second screen. The camera showed a cloud of dead marine life floating near a thermal vent, but that wasn't what caught her attention. Behind the cloud, something moved in the darkness. "Can you get closer?" she asked through the radio. The vehicle's lights revealed a group of strange creatures. They looked like no species anyone had ever recorded. These animals seemed to be surviving in the highly acidic water, but they were acting strangely, moving in unusual patterns. "They're dying too," Jai-Won's voice came through the speaker. "But they're not dissolving like the others. Something about them is different." Duha took screenshots and sent them to the other scientists. "We need to understand how these creatures are surviving longer than everything else. They might help us understand what's happening." The meeting ended with a grim conclusion. The world's oceans were facing a crisis unlike anything in human history. The change wasn't coming in decades as they had feared. It was happening now, and they had weeks, maybe months, to find a solution. As Duha looked at the images of the dying deep-sea creatures, she realized that time was running out. The ocean's complex web of life was unraveling faster than anyone had predicted. Unless they could find a way to stop the chemical changes, the damage would soon be beyond repair. The question wasn't just about saving a few species anymore. It was about preventing a disaster that could reshape life on Earth forever. Park Min-seo walked into the emergency meeting room at the Busan Deep Sea Research Institute with a plan. She had spent 3 sleepless nights working on it, and while others were still discussing the problem, she had thought of a possible solution. The room was packed with scientists from different departments. Dr. Kim Duha and Lee Ji-won sat at the front, showing their latest findings from the deep-sea expedition. The images on the screen showed more dead zones spreading across the ocean floor. Min-seo waited for a pause in the presentation, then stood up. "I may have an idea," she said, her voice clear and steady. As the chemical engineer for the institute, she had studied ocean chemistry for 15 years. "We can build automated stations to control the water's pH levels." The room went quiet. Duha turned to face her. "How would that work?" Min-seo walked to the front of the room and connected her tablet to the main screen. A design appeared, showing a large underwater station with multiple chambers. "These stations would work like giant filters," she explained, pointing to different parts of the design. "They would take in the acidic water, process it through special chambers, and release it back with the right phase balance. If we place enough of them near the thermal vents, we might be able to stop the problem at its source. That's impossible, someone said from the back of the room. Nothing we have can survive those depths for long. The pressure would crush any material we use. He's right, Jai-1 added. Our strongest deep-sea equipment only lasts a few months at those depths. These stations would need to work for years. Min-seo nodded. She had expected these objections. That's why we need to create something new. Our current materials aren't good enough, but what if we could make something better? She showed another slide, this one displaying the molecular structure of a new material she had been working on. We need to combine different approaches. Traditional engineering won't work alone, but if we add new technology. Duha leaned forward in her chair, studying the designs carefully. How long would it take to build these stations? That's the problem, Min-seo admitted. We need to develop the right materials first. Even then, building and placing the stations would take time. Time we might not have. The room erupted in discussion. Some scientists thought the idea was impossible. Others started suggesting ways to make it work. In the middle of the debate, the Institute's director stood up and raised his hand for silence. We've seen the reports, he said gravely. The oceans are dying faster than we expected. We need to try everything we can. He turned to Min-seo. What do you need to start? Min-seo straightened her shoulders. I need a team. Engineers, material scientists, anyone who can help develop new materials that can withstand extreme pressure. And we need to start immediately. The director nodded. You'll have everything you need. Duha, Jai-1, work with Min-seo. Your data about the thermal vents will be crucial for this project. As the meeting ended, people gathered around Min-seo's designs, offering ideas and suggestions. Duha pulled her aside. Are you sure this can work? She asked quietly. Min-seo looked at the latest images from the deep sea, showing more dead zones spreading across the ocean floor. No, she answered honestly. But right now, it's the best chance we have. They had no guarantee of success. The technical challenges were enormous. But as Min-seo looked at her colleagues already starting to work on the problem, she felt a spark of hope. Sometimes the biggest problems needed the boldest solutions. They had to try, no matter how difficult it seemed. The fate of the oceans depended on it. Choi Yun-ho stood in his naval architecture laboratory, staring at the failed pressure tests scattered across his workbench. For 2 weeks, he had been trying to create materials strong enough to survive the crushing depths of the ocean. Every sample had cracked or collapsed. The phone call from Park Min-seo 3 weeks ago had changed everything. She had explained their desperate need for new materials that could withstand extreme pressure while processing acidic seawater. Now time was running out, and they still had no solution. Yun-ho picked up one of the broken test cylinders and walked to his office. His grandfather's old metalworking tools hung on the wall, reminders of traditional Korean craftsmanship. As he looked at them, something clicked in his mind. He quickly dialed Min-seo's number. I need you to come to my lab right now, he said as soon as she answered. I think I found something. 30 minutes later, Min-seo arrived with Dr. Kim Duha. They found Yun-ho examining old photographs of traditional Korean metal vessels. Look at this, he said, pointing to a particular pattern in the metal. Our ancestors knew something we forgot. They created metal structures that were incredibly strong by folding the metal in specific ways. Min-seo leaned closer to look at the pictures. But how does this help us? We need something much stronger than traditional metals. Yun-ho smiled and walked to his computer. What if we combine old wisdom with new technology? He pulled up designs showing complex molecular structures. I've been working with experimental metamaterials, materials engineered to have properties that don't exist in nature. But they keep failing under pressure. He opened another file showing a new design. But if we apply the traditional folding patterns at the molecular level using modern nanotechnology. Duha watched as the computer simulation played out. The new material's molecules arranged themselves in patterns similar to the old Korean metalwork. Under simulated pressure, instead of breaking, they became stronger. The pressure actually helps the structure, Yunho explained, like how folded paper becomes stronger than a flat sheet. But we're doing this with advanced materials at the molecular level. Min Seo's eyes widened as she understood. Can you make it? I already started, Yunho said, leading them to another room. Inside, a machine was creating tiny samples of the new material. The first tests are promising. The material gets stronger under pressure, and it can process chemicals without breaking down. Du had touched one of the completed samples. It felt smooth but unusually dense. How soon can we make enough for a test station? That's the best part, Yunho said. The manufacturing process is simpler than our previous attempts. We can start production next week. Word spread quickly through the institute. By evening, teams were already adapting their station designs to work with the new material. In the main laboratory, Min Seo and Yunho worked late into the night, running tests and refining the manufacturing process. As they worked, Du-he received updates from ocean monitoring stations around the world. The acid levels were still rising, but now they had a real chance to fight back. It's amazing, Min Seo said, looking at the successful test results. We found the answer by combining the wisdom of the past with the technology of the future. Yunho nodded, carefully examining another sample. Sometimes the best solutions come from unexpected places. We just have to be willing to look in new directions. The breakthrough gave them hope, but they knew this was just the beginning. They still needed to build the stations and place them in the deepest parts of the ocean. But for the first time since the crisis began, they had a real chance of success. Submarine Commander Kang Hae-nul studied the depth readings on the control panel of the research vessel Deep Pioneer. They were already 7 kilometers below the ocean's surface, and they needed to go deeper. The first P regulation station lay secured in the vessel's cargo hold, ready for deployment in the Mariana Trench. Status report. Hae-nul called out to his crew. The submarine's reinforced hull creaked under the immense pressure. All systems normal, the first officer reported. The new hull material is holding steady. No signs of stress. Lee Ji-won sat at the science station, monitoring the water conditions. Acid levels are getting worse. We're seeing P values that shouldn't be possible at this depth. In the vessel's laboratory section, Park Min-seo and Dr. Kim Do-ho worked quickly to make final adjustments to the station's sensors. The device looked like a large metal cylinder covered in complex patterns, the result of Choi Yunho's breakthrough in materials science. The current is stronger than we expected, Hae-nul announced. We'll need to adjust our approach angle. The Deep Pioneer's lights cut through the darkness, revealing the steep walls of the trench. They had practiced this deployment hundreds of times in simulations, but this was different. One mistake could doom the mission and destroy their only working station. 2 kilometers to the target site, the navigation officer reported. We're picking up strong thermal vent activity ahead. Through the vessel's forward cameras, they could see the ghostly plumes of hot water rising from the ocean floor. The water around the vents swirled with strange patterns, evidence of the chemical reactions that were threatening ocean life worldwide. Beginning final approach, Hae-nul said calmly. Min Seo, is the station ready? Final checks complete, she responded. The processing chambers are primed. Once we place it near the vent, it should start working immediately. The Deep Pioneer crept forward, fighting against the powerful currents. Hae-nul kept his hand steady on the controls. Years of submarine experience had taught him to respect the ocean's power, especially at these depths where the pressure could crush their vessel in seconds. 1 kilometer, the navigation officer called out, current intensity increasing. Suddenly, their sensors began blaring warnings. A massive underwater current, stronger than anything they had detected before, was heading straight for them. Brace for impact, Hae-nul shouted, quickly adjusting the vessel's position. The current slammed into them, pushing the Deep Pioneer dangerously close to the trench wall. "Hull integrity holding," the first officer reported. "The new materials are working." Hanul guided the vessel back on course, his movements precise and controlled. They couldn't afford to rush, even with time running out. The station had to be placed exactly right for it to work. 500 meters to target, Jai-1 announced. "The vent activity is within acceptable parameters." The next 30 minutes passed in tense silence as Hanul carefully positioned the vessel. When they finally reached the deployment site, everyone held their breath. "Beginning deployment sequence," Min Seo said. The station slowly lowered from the cargo hold, its surface gleaming in the vessel's lights. As they watched the station descend, Duha's voice broke the silence. "Look at the readings. It's already starting to work." The station's indicators showed green across the board as it settled into position. The first step in their plan to save the oceans was in place. "Mission accomplished," Hanul announced, allowing himself a small smile. "Preparing for surface return." They had succeeded, but this was just the beginning. They would need to deploy hundreds more stations across the world's oceans, but they had proved it could be done. Human ingenuity and determination had passed its first real test in the fight to save Earth's oceans. Song Mi-ray peered through the high-powered microscope in the Deep Pioneer's onboard laboratory. The submarine had returned to the deployment site for their first inspection of the pH regulation station, but what they found was completely unexpected. "Dr. Kim, you need to see this," Mi-ray called out. As the research coordinator, she had studied deep-sea organisms for many years, but she had never seen anything like this before. Duha walked over and looked through the microscope. The water sample they had collected near the station showed something remarkable. Tiny organisms were swimming in patterns around the small particles of the station's processed water. "They're responding to the chemical changes," Mi-ray explained. "But look closer at their cell structure." Duha adjusted the microscope's focus. The bacteria had unusual features that seemed to protect them from the acidic water. Even more interesting, the water around them showed slightly higher fade levels than the surrounding area. "These bacteria are fighting the acidification naturally," Duha said, her voice filled with amazement. "They might be more effective than our station." Commander Kang Hae-nul's voice came through the intercom. "Dr. Song, we're detecting unusual readings from the station. Something is changing its operational patterns." Mi-ray and Duha hurried to the control room. The station's monitoring screens showed that its workload had decreased by 30%, but the water quality around it was improving faster than their calculations had predicted. "The bacteria are helping the station," Mi-ray said, studying the data. "They're multiplying around it, creating a natural barrier against the acidic water." Li Ji-1 joined them at the monitoring station. "If we could collect enough of these bacteria, we might be able to use them to enhance our other stations." "The problem is getting to them," Hanul said. "The current near the station is stronger than ever. Our collection equipment wasn't designed for these conditions." Mi-ray looked at the external camera feeds. The water around the station was now filled with swirling clouds of the bacteria. They seemed to thrive in the extreme conditions that killed other life forms. "We need those samples," she said firmly. These organisms could be the key to saving the oceans. The team spent the next hours planning a collection mission. The bacteria lived in the most dangerous part of the trench, where the pressure could crush their strongest equipment. Regular collection tools would fail instantly. "What if we modify the station's intake system?" Jai-1 suggested. "We could use it to filter out the bacteria while it processes the water." "That's too risky," Hanul warned. "One wrong move could damage the station. We can't afford to lose it." As they discussed options, Mi-ray noticed something on the monitors. The bacteria were spreading, following the currents away from the station. Soon, they would disperse too far to collect. "We have to try," she insisted. "These organisms evolved to survive in these conditions. Nature found a solution before we did. We need to learn from it." Duha nodded in agreement. Sometimes the best answers come from the most unexpected places. We built the station to save the ocean, but maybe the ocean is showing us a better way. They had found a potential natural solution to the crisis, but reaching it would be their most dangerous mission yet. As the team prepared their collection equipment, they knew they were racing against time. The bacteria could disappear as quickly as they had appeared, taking with them perhaps the best hope for saving Earth's oceans. Engineer Yang Ta-Wan felt the deep Pioneer shudder as another strong current hit the vessel. They had been trying to collect bacteria samples for 6 hours, but each attempt had failed. Now, warning lights flashed across his engineering console. "Commander, we have damage to the outer hull," Ta-Wan reported. "The pressure seal on Section 3 is weakening." Commander Kang Hae-Newell's face remained calm, but his voice was tense. "How long can we stay at this depth?" Tai-Wan checked his instruments. 2 hours at most. After that, the seal might fail. In the laboratory, Song Mai-Rei and Dr. Kim Do-ha watched their precious bacteria samples drift away in the current. Their collection equipment kept breaking under the extreme pressure. "We need a new approach," Ta-Wan said, studying the station's design on his tablet. "Instead of bringing the bacteria up, what if we grow them down here?" Li Ju-wan looked up from his monitoring station. "How? We don't have a cultivation system on board." "No," Ta-Wan agreed, "but we have something better." He walked to the main screen and pulled up the schematics of their pH regulation station. "We can modify the station to become a bacterial cultivation system." Park Min-seo joined them at the screen. "The station already has temperature controls and water processing chambers. If we reprogram it." "Exactly," Ta-Wan said. "We can create perfect growing conditions for the bacteria. Let them multiply where they already live." Commander Hae-Newell checked their oxygen reserves. "We have 90 minutes before we must return to the surface. Can you make these changes in time?" Tai-Wan nodded. "The basic systems are already in place. We just need to adjust them." He turned to Mai-Rei. "What conditions do the bacteria need to grow?" Mai-Rei quickly listed the requirements. The bacteria needed specific temperatures, pressure levels, and chemical balances. Tai-Wan entered these details into his tablet, creating a new program for the station. "Starting system modification," he announced. His fingers moved quickly over the control panel, rerouting power to the new cultivation chambers. The minutes passed tensely as Tai-Wan worked. Every few minutes, the hull creaked under the pressure, reminding them of their limited time. Do-ha and Mai-Rei helped by monitoring the bacteria's responses to each change. With 30 minutes remaining, Tai-Wan made the final adjustments. "Cultivation system is online," he reported. "The station is now a bacterial nursery." They watched the station's monitors carefully. At first, nothing seemed to happen. Then Mai-Rei pointed to a reading on her screen. "The bacterial count is rising. They're multiplying." The team gathered around the monitors, watching as the numbers continued to climb. The bacteria were growing faster than they had hoped, already spreading through the station's chambers. "The pressure seal is holding," Tai-Wan reported, checking his instruments one last time. "The station should be able to maintain these conditions indefinitely." Commander Hae-Newell nodded. "Then it's time to leave. We've done what we came to do." As the Deep Pioneer began its ascent, they continued to receive data from the modified station. The bacteria were not just surviving, they were thriving. Their natural ability to counter ocean acidification, combined with human technology, was creating a solution none of them had imagined possible. "Sometimes the best plan is the one that works with nature, not against it," Mai-Rei said, watching the bacterial colony readings continue to rise on her screen. They had turned their technological solution into a home for nature's own answer to the crisis. 3 months after the successful modification of the first station, Dr. Kim Do-ha stood at her desk in the Busan Deep Sea Research Institute, reviewing the latest ocean monitoring data. The changes she saw in the numbers made her smile for the first time in months. "The phase levels are stabilizing," she said to Li Ju-wan, who sat nearby analyzing deep-sea camera footage. The bacteria are spreading exactly as we hoped. Jai-1 nodded, turning his screen to show her the underwater images. Look at this footage from near the first station. The coral is starting to recover. The images showed small patches of living coral growing near the modified station. Fish and other sea creatures had returned to the area, drawn by the improving conditions. What had been a dead zone just months ago was showing clear signs of life. Hark Min Seo entered the office carrying more reports. The other research stations are sending similar data, she said. The bacterial colonies are establishing themselves around each new station we install. They're creating protected zones where marine life can survive. The team had worked tirelessly to replicate their success. Following engineer Yang Ta-1's design, they had modified and installed 15 more stations across the Pacific Ocean. Each one now served as both a pH regulator and a bacterial nursery. Song Mairei's research on the bacteria had revealed something remarkable. The organisms are evolving, she explained, joining the group. They're adapting to different ocean conditions. Each colony is slightly different, perfectly suited to its location. Commander Kang Hae-Newell arrived with news from the latest deployment mission. The European and Indian Ocean teams have successfully installed their first stations, he reported. They're using our modified designs, and their bacterial colonies are growing well. Du-ha walked to the large wall screen showing a map of the world's oceans. Blue dots marked each functioning station, with green areas showing where the bacteria had spread. The coverage was growing steadily. We didn't just find a solution, Min Seo said, looking at the map. We found a way to help the ocean heal itself. Choi Yun-ho, whose material science breakthrough had made it all possible, studied the latest pressure test results from the stations. The structures are holding perfectly, he said. The combination of our technology and natural processes is working better than we imagined. The Institute's director called them all to the conference room. Scientists from around the world had joined by video call to share their results. Every team reported the same findings. Ocean acidification levels were dropping, and marine ecosystems were beginning to recover. What we've achieved here is remarkable, the director said. By working with nature instead of trying to control it, we found a way to save our oceans. Du-ha thought back to that late night when she first discovered the crisis. The situation had seemed hopeless then. But human creativity, combined with nature's own solutions, had found a way forward. Our work isn't finished, she told her team. We need to keep monitoring, keep improving. But we've proved something important. When we face a crisis, we can find answers in unexpected places. As she looked at the recovering ocean data, Du-ha knew they had learned a valuable lesson. The greatest solutions often came from combining human innovation with nature's wisdom. They had not just saved the oceans, they had discovered a new way of solving environmental problems that would guide future generations.